A Bluffer's Guide to Encryption in the Cloud, my top 100 knowledge tips. In cybersecurity, the teaching of cloud security is often weak, so here are my top 100 things to know about encryption in the cloud. Overall, I focused on AWS, but Azure is likely to be also applicable in most areas. Keys are stored in the KMS or Key Management Store. In Azure, this is named Key Vault. The cost of using a key in KMS is around $1 per month, pro rata hourly. When a key is disabled, it is not charged. With AWS KMS, we use a shared customer HSM or hardware security module. And with AWS Cloud HSM, it is dedicated to just one customer. For data at rest with file storage, we can integrate encryption with Amazon EBS, Elastic Block Storage, and Amazon S3. EBS is the type of disk storage that we would mount onto a running instance. Amazon EBS drives are encrypted with AES 256 with XTS mode. For AWS managed keys, a unique key is used for every object within S3 buckets. Amazon S3 uses server-side encryption to store encrypted data. The customer can use client-side encryption to encrypt data before it is stored in the AWS infrastructure. AWS uses 256A Advanced Encryption Standard AES, GAWA Counter Mode or AES GCM for its symmetric key encryption. In AWS S3, by default, all objects are encrypted. A customer can use client-side encryption to encrypt data before it goes into the AWS infrastructure. For data at rest, for databases, we can integrate encryption into Amazon RDS, which is Amazon's relational database service, and Amazon Redshift, which is AWS's data warehousing. For data at rest, we can integrate encryption into Elastic Cache, AWS's content caching service, AWS Lambda, AWS's serverless computing service, and Amazon SageMake, which is AWS's machine learning service. Encryption keys are tokenized and have an ARN or Amazon resource name and also an alias. An example of an ARN for a key is ARN:WS:/KMS:US-East1, that's the region that the keys are stored. Then we'll see a user ID, a key, and then a GUID ID. An example alias is Bill's key. Both should be unique within the user's account. To define a KMS key, we can either use its key ID, its key ARN, its alias name, or its alias ARN. We can link keys to other AWS accounts. For this, we specify in the form of ARN:AWS:"IAM, and then the AWS ID: root. And where the AWS ID is the ID of the other AWS account. To enhance security, we can use the AWS Cloud HSM. For simpler and less costly solutions, we typically use KMS. For Cloud HSM, we pay per hour, but for KMS, we pay for the usage of the keys. An application of the keys is restricted to defined services. Key identifiers and policies are defined in a JSON key value pair for data objects. Each key should have its own unique GUID. Users are defined and roles are also defined with an ARN. With the usage of keys, we can have key administrative permission and key usage policies. There is an explicit denial on a policy if there is not a specific allow defined in the policy. For key permissions, we have fields of SID, which is the descriptive name of the policy, effect, which is typically allow, principal, which is the ARN of the user/group, action, such as create, disable, and delete, and resource. A wildcard of star allows or disallows all. To enable a user of root access to everything with a key would be SID enable IAM user permissions, effect allow, principal AWS and then the ARN for root, action KMS:**, resource star. The main operations within the KMS are to encrypt, decrypt data, sign, verify signatures, export data keys, and generate and verify MACs or message authentication codes. Keys are either AWS managed, such as for Lambda services, or customer managed. These are keys that are created and managed by the customer. Custom key stores are where the customer has the complete control over the keys. The main usage of keys are in EC2, compute, EBS, elastic block storage, and S3 storage. AES symmetric keys or an RSA key pair can be used to encrypt and decrypt data. RSA uses 2K, 3K, or 4K keys, and with either RSA PKCS1 version 1.5 or RSA PSS padding. RSA PCKS1 version 1.5 padding is susceptible to the Bleichtenbachter's attack, so it should only be used for legacy applications. For all other applications, we should use RSA PSS padding. For RSA, we can have a hashing method of SHA-256, SHA-384, or SHA-512. In RSA, we encrypt with the public key and decrypt with the private key. For signatures, we can either use RSA or ECC signing. For RSA, we have 2K, 3K, or 4K keys, whereas ECC signing uses NIST P256, NIST P384, NIST 521, or SEPT 256K1. The SEPT 256K1 curve is used in Bitcoin and Ethereum. For MACs, message authentication codes, Bob and Alice have the same shared secret key and can authenticate the hash of a message. In KMS, we have HMAC224, HMAC256, HMAC384, and HMAC512. KMS uses hardware security modules, HSMs, with FIPS 140/2, and which cannot be accessed by AWS employees or any other customer. Keys should never appear in an AWS disk or backup and only exist in the memory of the HSM. They are only loaded when required. Encryption keys can be restricted to one region of the world unless defined by the user. With symmetric keys, the key never appears outside the HSM, and for asymmetric keys, that's public key encryption, the private key stays inside the HSM and only the public key is exported. AWS CloudWatch shows how and when encryption keys are being used. The minimum time that can be set for a key to be deleted is 7 days and up to a maximum of 30 days. An organization can also create its own HSM with the Cloud HSM cluster. When a key is then created in the KMS, it is then stored in the cluster. The usage of encryption keys should be limited to a minimal set of service requirements. If possible, separate key managers from key users. With the key management role, key administrator, we typically have the rights to create, revoke, put, get, list, and disable keys. The key management role will typically not be able to encrypt and decrypt. For a key user, that's key worker role, we cannot create or delete keys and typically focus on tasks such as encrypting and decrypting. Have a rule of minimum rights access and simplify user access by defining key administration and usage roles. Users are then added to these roles. Avoid manual updates to keys and use key rotation. The system keeps a track of the keys that are rotated and can thus use ones that were previously defined. The default time to rotate keys is once every year. Key rotation shows up in the CloudWatch and CloudTrail logs. KMS uses PCI DSS Level 1, FIPS 142, FedRAMP, and HIPAA. AWS KMS matches to FIPS 142 Level 2. AWS Cloud HSM complies with FIPS 142 Level 3 validated HSMs. AWS Cloud HSM costs around $1.45 per hour to run, and the costs end when it is disabled or deleted. The Cloud HSM is backed up every 24 hours, and where we can cluster the HSMs into a logical HSM. Cloud HSM can be replicated into AWS regions. AWS KSM is limited to the popular encryption methods, whereas Cloud HSM can implement a wider range of methods. Cloud HSM can support methods such as 3DES within AWS payment cryptography. This complies with the payment card industry PCI standards, such as with PCI PIN, PCI 2P2PE, and PCI DSS. In the Cloud HSM for payments, we can generate CVV, CVV2, and ARQC values, and where sensitive details never exist outside the HSM in an unprotected form. With the Cloud HSM, we have a command-line interface where we can issue commands and is named Cloud HSM CLI. Within Cloud HSM CLI, we can use the gen sim key command to generate a symmetric key within the HSM, and where we use -T for the key type, 31 is for AES, -S for the key size, 32 bytes for a 256-bit key, and -L is the label. SIMKey -T 31, -S 32, -L AES 256. With Gen SIMKey, the key types are 16 generic secret, 18 RC4, 21 triple DES, and 31 AES. Within the Cloud HSM CLI, we can use gen RSA key pair command to generate an RSA key pair, such as where we use -M for the modulus and -E for the public exponent. Gen RSA key pair -M2048 -E65537 -L my key. AWS Cloud HSM is integrated into AWS CloudTrail, and where we can track user, role, or an AWS service within the Cloud HSM. With AWSM payments cryptography, the 2-key TDES or 2-key triple DES key has a 128-bit equivalent key size. The PIN encryption key or PEK is used to encrypt PIN numbers and uses a key triple DES key. This can store pins in a secure way and then can decrypt them when required. S3 buckets can be encrypted either using Amazon S3 Managed Keys, SSE S3, or AWS Key Management Service, or KMS. There is no cost to use SSE or Amazon Managed Keys. For symmetric key encryption, AWS uses envelope encryption, and where a random key is used to encrypt the data, and then a key is encrypted with the user's key, and then this key is then encrypted with the user's key, AWS should not be able to access the key that is used for encryption. The default in creating an encryption key is for it to be only used in a single region, but this can be changed to multi-region, and where the key can be replicated across more than one region. In AWS, a region is a geographical area and which is split into isolated locations. US East 1, North Virginia, and US East 2, Ohio, are different regions, while US East 1A, US East 1B, and US East 1C are in the same region. A single region key for the US East 1 region would replicate across US East 1A, US East 1B, and US East 1C, and not to US East 2A, US East 2B, and US East 2C. When creating a key, you can either create it in the KMS, import as a key, that's bring your own key, create it within the AWS Cloud HSM, or create it in an external key store, that's hold your own key. For keys stored on-premise, we can use an external key store, XKS. This can be defined as hold your own keys, or HYOKS, and where there is no entity in AWS which will be able to read the encrypted data. You can use BYOK, or bring your own key, with KMS and import your own keys. KMS will then keep a copy of this key. With XKMS, we define a proxy URI endpoint with proxy credentials of an access key ID and a secret access key. To export keys from the AWS Cloud HSM, we can encrypt them with an AES key. This is known as key wrapping and is defined in RFC 5648 for padding with zeros, or RFC 3394 without padding. A strong password should always be used for key wrapping. AWS encryption operations can either be conducted from the command line or within an API, such as with Python, Node.js, or Golang. With KMS, the maximum data size that we can encrypt is 4K bytes. For symmetric key, 190 bytes for RSA 2K, 318 bytes for RSA 3K, and 446 bytes for RSA 4K. An example command to encrypt a file for 1.txt with a symmetric key encryption is AWS KMS encrypt -key ID -plaintext -query -output. I've given these examples in the related blog. In Python, to integrate with KMS, we use the Boto3 library. The standard output of encrypted text is in a byte format. If we need to convert it to a text format of the ciphertext, we use a base64 format. The base64 command we can use to convert byte format to base64 is with base64 -i 1.out -decode greater than 1.encrypt. The XXD command in the command line allows the ciphertext to be dumped to a hex output and can then be edited. We can then simply convert it back to binary. You cannot encrypt data with elliptic curve keys. Only RSA and ASA can do this. Elliptic curves are used to sign data. If you delete an encryption key, you will not be able to decrypt any ciphertext that has used it. We can store secrets, such as application passwords, in a secret manager. An example of a secret name of my secret passphrase and a secret string of QWERTY123 has AWS Secrets Manager create secret --name my secret passphrase --secret string QWERTY123. In China regions, along with RSA and ECDSA, we can use SM2 KMS signing keys. Also in China regions, we can use SM2 PKE to encrypt data with asymmetric encryption. You can find out more at asecuritysite.com/AWS. Thank you.